we had left off with looking at different types of bias when we're making decisions. And we had left with framing as one of our last ones, where framing is just how we're presenting information and how we might think of that information. And I use the example of when people have, say, a word problem, and they're deciding, out of all of these things that you've given me, which pieces of information are relevant. You might choose to flag more pieces of information as important than you need to. And I use this standard example of those, you have two trains leaving from stations and they're this far apart and they travel at these speeds. People often sort of overcomplicate those things, especially if you're given extra information, which is usually a strategy on the part of the person asking the questions. But when we're looking at this here for our example, we're going to talk about framing things in terms of gains and losses. So do you have the chance to get something out of it or to save something, or are you losing something or missing out on something? This could also be framed as a good outcome versus a bad outcome, which can actually change how we tend to respond. And I believe last time I had given you the hint that if this is something you're curious about, our own Dr. Marcia PSYCH used to do a bunch of research in this area, looking at specifically decision-making with pigeons and humans, but also looking at how the framing and how the information is presented can affect how we think about these things. And humans have a lot of the same biases as our pigeons do. But some of that actually ties into our availability heuristic that we talked about before, where we tend to assign more importance, or it's easier for us to remember some things than others. So I think I use the example of when you're driving in, you notice all of the red lights, but none of the green lights. Same thing, but with gains and losses. So you might overestimate how often you win something. It's why some people really enjoy going and gambling, because that win is associated with the big dopamine rush of something great happened. And now when you think of gambling and the odds of winning, you have this big, strong memory of winning and feeling great, so you might be more likely to take risks in the future if you want sort of that payoff. But we have lots of things that can influence that. But here, I had tried to come up on the spot with an example and then realized I already had a built-in example. So if we have our gain framing, we would say, which would you choose to combat a new plague on Mars? You adopt a new untested vaccine and 100 Martians will be saved. Or you adopt a new untested vaccine and there is a 1 in 4 probability that 400 Martians will be saved and a 3 in 4 probability that no Martians will be saved. And if you work out the odds on this, so if we take across all probabilities, in this situation we would rather take, make sure I say it right, we would rather take the sure thing in this situation. So we would look at this and say that number 1 is by far the most appealing of these potential options, because we don't want to take the risk on it. But if we frame it as a loss, we say, okay, we're adopting a new vaccine, 300 are going to die, or there's a 1 in 4 probability that they all die. So exact same numbers, exact same framing, which one is more appealing? You're now going to take a chance. So that sort of 1 in 4 probability that no one dies, 3 in 4 that they all die, that all of a sudden makes it more appealing to us. So we'll switch from a safe option for wins to risky options for losses. And it's all about, are we framing it as saving people or losing people, completely changes our response to the exact same question. And so there's all sorts of stuff you can do, adjusting these numbers, adjusting the scenarios, and this pattern tends to persist. And in case you're curious, the pigeons do the same. And then our last slide here is getting back to one of the concepts that I had mentioned but not had a slide for earlier, and this is looking at a dual process theory of systems that we use for making decisions. So we have our system one, or our FAST system, where this is when we try and come up with, or we're relying on our heuristics, we're relying on those sort of quick and dirty solutions, things that might work, and if they work, it gets us a quick solution, and we don't have to think about it anymore. We might be able to save resources, but the cost to this, or the risk to this, is that we're not guaranteed to find an actual solution. Some of the stuff that can get involved in this, and as we might have seen already looking at some of our heuristics and biases, is that this might rely on experience. So I've seen this before, or I remember seeing this recently, but we can also have emotion and intuition involved. We've mentioned before, I believe, that humans are easily swayed by a good story. Our intuition can sometimes override proper logic, and that can have that emotional component. And because of that, it can rely on some of those emotional centers in the brain rather than just sort of rationalization and pulling information in a more logical way. And then, of course, the contrasting system, system two, is much more slow, much more resource intensive, but it would be more logical, sort of intentional approaches. So this would be something like one of our algorithms, where we are trying to take that sort of step-by-step predictable pathway to make sure that we find a solution. So we end up recruiting a lot of those higher brain areas, so places where we're making associations, thinking about prior experiences maybe, and prior solutions, but also looking at, well, what's the most logical way that I make sure that I'm getting a solution, that I'm not just trial and erroring it and taking that risk of no solution at all. All right, and I think before I had already gone into that idea of with a fast and slow, this can also be processing in general, where we can have sort of, we rely on instinct and stuff that we've carried out multiple times in the past. So things like when you're driving to school, you have that automatic processing of, I take the same route every day, it's always the same, I don't have to think a whole lot about it, no big deal. Whereas if you encounter, say, construction or a traffic accident, all of a sudden you now have to switch over to effortful processing, that slower system, and you have to think up a new solution. So you could see that even with our problem solving here, where you had been trying to rely on heuristics, but if you keep hitting dead ends, you might have to switch to a much more effortful and logical solution. It completely depends on the scenario.